A very good morning to you all. Welcome to the manufacturer's latest webinar, The Fourth Industrial Revolution and the Cognitive Factory, sponsored by our friends at IBM. My name is Nick Peters. I'm the editorial director here at the manufacturer. Now, before we get going, we've just got a couple of housekeeping points. If you've got any questions throughout the webinar, please use the Q&A button, which you'll see at the bottom of your screen. And we'll get to as many of those questions as we can at the end of the discussion. When you click it, it gives you the opportunity just to write in text your questions. We will be gathering them as we go along. After the webinar, we're going to send all registrants a copy, including video of the slides and all our contact details. So if there's anything you wish to follow up with us about after the event, you will, of course, be able to do that. Now, the overall focus of this webinar is the fourth industrial revolution, Industry 4.0, as the Germans call it, or as we prefer, 4IR. Within that topic today, we're going to be looking at a number of areas. These include the industrial Internet of Things, in other words, connected devices within a production line, within a factory environment, and so on. Analytics, how information from data sources such as sensors and elsewhere can be digested and acted upon to improve your efficiency. And the idea of the cognitive factory. We're going to be taking a look at how factories can start to encompass elements such as machine learning and artificial intelligence. Joining me today to present and discuss 4IR and the cognitive factory is Graham Cox, IBM Industry Solutions Lead for the industrial sector. Good morning, Graham.
Morning, Nick. Good morning, everybody.
And also joining us is Professor Keith Jackson, Chief Technology Officer at Meggitt PLC. Professor Jackson's been the CTO at Meggitt since April 2013 and is responsible for the technology strategy and research there. Morning, Keith.
Good morning. Good to speak to you.
Okay, well, thank you very much for joining us. Without further ado, I'm going to pass you all over now to Graham from IBM for this discussion on the cognitive factory and 4IR.
Hello and welcome everyone to this webinar on the fourth industrial revolution and the cognitive factory. My name's Graham Cox of IBM's Industry Solutions Business Unit. And today I'd like to share some of IBM's strategy and direction for cognitive manufacturing and also to discuss some of IBM's solutions in this area. On this first slide, we're looking at the concept of Industry 4.0, which began 5 or 6 years ago when the German government initiated its strategic programme for advanced manufacturing. The idea being that the industrial transformation is now hitting its fourth revolution. Over history, we've seen major leaps forward in manufacturing technologies, beginning with the first industrial revolution in the late 18th century, with the introductions of steam engines and automation, moving over to electrification and mass production processes in the second half of the 19th century. And in the latter part of the 20th century, we saw the development and introduction of computing systems and information technologies, which facilitated a further leap forward. And this went hand in hand with the massive growth of international trade. And then today, we've arrived at the era of cognitive manufacturing. And what we mean by that is the application of sensors and data gathering techniques across all manufacturing operations. This has enabled the application of data science techniques and advanced analytical methods to build statistical and predictive models, along with advanced manufacturing capabilities such as advanced robotic systems and additive layer manufacturing. We also now have the capability to bring in unstructured data in the forms of images, video, technical publications, even weather conditions into the digital world, and to use the analysis of that unstructured data to deliver the cognitive insight into what's happening in the physical world. There are several other technologies that we could include in this chart. And one of the interesting things about the fourth industrial revolution is that there's no universal definition of what it does or does not contain. There's also debate about the use of the term revolution, as many have observed that the progress in industrial technology has in fact been continuous over history and hasn't been neatly packaged into waves or sequences as shown here. Now, I don't intend to address those aspects of the 4IR debate today, but I would conclude that we've already observed the pervasiveness and maturity of many of these technologies, including sensors and widespread equipment monitoring and data gathering, the availability of cloud computing, the Internet of Things, advanced analytics and artificial intelligence or cognitive capabilities, and all of these offer benefits and value into the manufacturing sector. Although there's potential complexity in these new technologies, what we'd like to look at today is how organisations can cut through that complexity and take practical steps to gain business advantage. I'll also focus on the cognitive aspect and the IBM solutions available today, which can deliver genuinely innovative capabilities and benefits. And with that, I'd like to hand over to Keith Jackson, Chief Technology Officer of Meggitt, who's going to take us through some of the work that's been going on within Meggitt.
Thank you, Graham. That's a very good introduction. Today, I'd like to talk to you a little bit about Meggitt and our interpretation of Industry 4. And I deliberately say our interpretation of Industry 4 because, as Graham said, it's something which has got a very big scope, and there's a lot of confusion about what it is and what it means to different businesses. So it ranges from additive layer through to how you feed information to your designers, how you manage your supply chain, how you optimise your factory, research that you might put on for data standards and data security. And a lot of people that I talk to about Industry 4 get quite confused by the whole thing because the scope is quite vast and it's quite different to perhaps what they're used to. But the one thing you can be fairly sure of as you look at this is things are changing. We're experiencing this in our normal lives, whether it's through mobile data or cloud computing or the analytics and the information that's built up behind it. And we can see that the velocity and vivacity of data is changing. And it's not just changing here, it's something that's changing globally with a globally connected world. And that's interesting for us because it's pace, and it's a real pace, and it's an opportunity. But it's also a risk, and I think we have to be careful about that and understand the risk that happens. We just need to reflect a little bit and say, from a manufacturing industry point of view, and where we sit with our credibility and success ratios, and what we're now doing is perhaps crashing that together with an IT industry. And an IT industry has a very different pace of development and has a very different success ratio in the number of successful projects to unsuccessful projects. And so we have to go into this with our eyes wide open about how we make this work. And we need to also understand that maybe some of the people that we have in our organisations, our normal manufacturing organisations, may not be 100% equipped to take us on this revolution or this journey, because it's quite different to the journey that we go through. So, having sort of added to that confusion, I'd like to talk to you about how we in Meggitt have addressed this, and perhaps that will give some insights to others. And my one piece of advice that I step back and say is, you'll hear lots of advice about Industry 4 and what you can do with data, but you have to step back and say, what does it mean for my business? What does it mean for our business? And how am I going to make this useful? If you just think by collecting lots of data and pouring it into a massive bit bucket, you're going to get something out of it that's useful. The answer is you may, but I think you may not, and it may turn into an expensive mistake. So you have to step back and think about what you're going to do. And this is actually exactly what we did. And we'd actually come up with our digital Meggitt and manufacturing story before we'd even heard of Industry 4. So we'd coined and come up with M4, which was just a lucky happenstance. And then one of my guys came back from Hanover and said, in Germany, they're talking about this thing called Industry 4, and it looks just like what we're talking about. And so we do feel from that point, slightly smug, if you like, that what we were planning aligned with what other people who were thinking about this were coming up with. So from our point of view, we felt, what are the problems that we have to address? And we largely supply components and systems into the aerospace industry. So for those of you who are not familiar with it, the aerospace industry is quite a different business to many other businesses. Typical life for an aircraft when in service, maybe 30 years. And then you may be supplying parts for those aircraft for another 20 years after they've stopped being made. So you've got a 50-year life cycle. And that's a 50-year life cycle of parts that have got to be made exactly the same way as they were at the start. You can't just change them, or if you do, there's quite a big accreditation and certification process. So the tracking and the knowledge of how you make them is very important. People that make them in volume, when they're in the volume part of their life, may not be working for you when you're making them towards the end of their life. The products will outlive the working careers of the people that make these things. So the knowledge and the skills that you use to produce a product, very important to us. The traceability of knowing exactly what went into the product is very, very important to us. So the tacit knowledge, the explicit knowledge is critical to make the product work. And also we have to run efficient factories, just like everybody else that does. We cannot have separate lines which only get used once or twice a year. They wouldn't be maintained. We have to work and understand how that all works through a common factory. And people talk about factories of the future making batches of 1 or batches of N, and we have to think about how our factories can make our production runners, but also look after our customers for the long term on the low volume that keeps coming through. So you can see perhaps we have a very different problem, but I'm sure there are some elements of that that are relevant to other businesses. So we started out and looking at that and thought about what's the first thing that we wanted to address with this digital manufacturing. And in our manufacturing, I've mentioned people quite a bit, and people are very important to us, and our people will continue to be very important to us. We hear a lot about robots and mechanisation, but the volumes and the accuracy and the precision and the way and the complexity of our products means that people are and will be important to us for a long time. But it's very important that we harness their skills, and we also harness their intellectual property, horsepower, to make sure we do a better job over time. So we started out with our first Industry 4 application, a workbench called Claw, which was a closed-loop adaptive automated workbench. And really what we tried to do with this, the Claw workbench, was apply a lot of existing technologies to help our engineers do a better job of building their products, but also help us learn from what they know and capturing the knowledge. So we went into it very clearly right from the start, as this was about helping, assisting and learning and doing a better job. So what does the Claw workbench do? You can see a little bit of it on a picture on the slide, but as well as presenting things like digital work instructions and using guidance systems and digital twins to help people understand how to build their product, it also weighs the part, sets the tools, measures the torques, measures the humidity, measures the temperatures, and it gathers a complete record of how that product is built, but does it quite passively. The person involved doesn't have to be aware that it's doing this. And this is done for good reasons, actually. One of the things I'll talk about later is if you're going to start analysing data, you need to have good quality of data, and that data's got to be at the right precision and sampled at the right time. And the best way to ensure that it's sampled at the right time and at the right precision is to do it passively and automatically in the system. So another reason why we heavily involve the people involved in this is because you can gather data in the manufacturing process, but data is useless unless you have interpretation to turn it into useful information. And the people that are actually producing these systems and producing the output are the people that can really help you turning the data into useful information. So our system, our Claw workbench, has been designed all the time to help them capture and put their input and their insights into the system and the manufacturing. In fact, taking that to another level, we use a system called the Meggitt production system, which is a sort of a philosophy of the way we work within Meggitt. And this helps us solve issues if we see some anomalies in the data by working directly with the people on the shop floor to solve the problems. And we think that's quite an important cultural understanding about how you use the information and how you get the best out of it. So you can see here we've got a workbench. It joins together there's some existing technologies, some new technologies, but it joins them together in a novel way, and it's novel about the way it interacts with the users. And from that we can collect information which helps us work with them to do a better job. Just one warning that comes out of this, and thinking about events that have happened recently as we talk about data, is we have to all be very careful not to become hostages to our data and hostages to our information. So all of this has been quite a lot of work that goes on in the background about how we protect that data. The information from these Claw workbenches is fed into a cloud system, but it's a private cloud system that's administered and understood by us, and is obviously what you'd expect in terms of protection and firewalls to make sure when data goes outside of that cloud how it's managed. But we do have to be very aware of recent events that some people may be trying to in a hostile way break through into our systems. And knowing how you make things, what you're making, when you're making it, and where you're making it is as valuable information as your patents and your designs and your intellectual property. So I just sort of read that as a little bit of a warning about the knowledge of your manufacturing. So that's one example of our manufacturing process, the manual assembly operations. But then we extended this thought out to say, well, that's only looking at a bit of the process. The entire process of how do you make a factory which really for us uses the digital data to optimize the factory. So how do we understand the scheduling? How do we understand the best routing of our products? How do we improve as things go through manual assembly, testing, machining, painting, stores, inventory? Collecting all of that information is something that we want and need to do. And again, we talk about how we collect that passively without user involvement. Not because we don't trust the users, but we want to collect that data to the right resolution at exactly the right time so we can put analytics on it. And also, again, we think about how do we engage with our people in the factory so they see this for what we want it to be, which is something positive about the quality and productivity that we can get through their factories. So we all accept using apps on our phones to find our way to a restaurant or to find our way to the theatre, but using those mobility apps actually within the manufacturing environment and how that helps us do our job is perhaps an even more powerful use for us, and people can engage in a positive way. An interesting thing that comes out of this is we can make things smart, and we can make things smart, even the boxes that our products are carried in, because if you've got a box and it's tagged and you know where it's been and you know where it's going, and it may not even have any local processing power, but you have actually built up intelligence and knowledge about that box and its journey as it's made its way through the system. So you've got the opportunity, in a way, to make that box smart, because you can trace it, you know where it's been, you know the time it's taken. You could make a coffee cup smart, because if you tag it and you know where it's been and you know where it's used, you can tell if it should go in a dishwasher or it should be left on the desk because it's going to be used again. Slightly flippant example, but actually making things smart in the factory doesn't necessarily involve putting computing power and a load of sensing into everything you're doing. Some things you will, some things you might get enough information by context and knowing position and where it's been. And this is part of the things that we think about this in our factory design. We call it where is the brain, because the brain doesn't have to be where you would think it would be. And in fact, you don't always want to put the brain directly on the device, because if there's decisions being made, you have to think about how those decisions are made for the best in conjunction with other parts of the system. So if you have a rescheduling opportunity, if I reschedule a product going through part of the factory, I do have to think about the downstream impact as I reschedule that. And why are we doing all of this? Well, we want to run our factories better and learn how to schedule our factories better and get better use and higher quality out of them. But the other phrase we use is we want to gather the DNA for our products. So as we produce our products, we keep precise DNA records of how they are built, fully digitally collected in a way that can be analysed. But we cross-cut the DNA. We look at the DNA of a product as it goes through the factory, but we can also look at the DNA, say, of a piece of equipment or a resource in the factory. So as things change and as the workload changes, you will see mutations in the DNA. Some of those mutations will be good. Some of those mutations might be an indicator that things are going to change in a way you don't want them to change in the future. So that's where we start thinking about how we use the DNA from the product and the factory to develop quality and predictive analytics in where we're going. And just to talk a little bit about that, I've mentioned quality of data, and coming full circle a little bit. Quality of data is really important, and I will mention it again, because people seem to think you can collect lots of data and get lots of useful information, and you might. In some systems where you've got masses of information and you've got a fairly tight distribution around it, you may be able to use this. But as engineers, We know if we take a length of bar of a length, we would put a tolerance on it. And if we took 3 bench lengths of bar of a length and we joined them together by a welding process, those tolerances would add up. Data that we use for decision making has exactly the same issues. It has tolerances and it has distributions around the data. And so you have to think quite carefully about what you want to do with that data, because you might think you've got the right raw data, but if it's sampled at the wrong time, if it's sampled at the wrong position, or you're trying to compare A with B, but it's scattered because it's come from different times and different sources, you may be forming unfair comparisons and not going to be able to make the decisions that you want to be able to make. And it's particularly relevant for our sort of business where the volumes are not huge. It may, in a consumer electronics or automotive, where you're running a lot more product through your lines, your statistics will help you. Statistics doesn't necessarily help us in what we're trying to do. And then when you think about the precision about it, you need the data, you have to think of the cost to gather that data and the value you get out of it. If I can come up with a clever scheme which saves me £100,000 in my supply chain, but it costs me £20,000 per year to implement and manage that scheme, you can quickly see that after 5 years it wasn't such a good idea, which reflects back right to the beginning of think about what you're trying to do, think about what's necessary for your business. So that's a really quick sort of canter through what we've done at Meggitt, but just to summarise, it's about, from our point of view, Industry 4, really big topic, means many things to many people, but from our point of view we thought about what do we want it for, what do we need it for, very clear about the problems involved and what we're trying to tackle, and then we thought about the solutions and the data, and we've also recognised where we haven't had the skills to do what we want to do, we've had to bring in expertise from the side. We are a manufacturing and engineering company in our specialist aerospace market. We have a great deal of skills, but we've had to bring in some extra counsel to help us with some of the data problems around it. So with that, I'd like to say thank you very much. I hope you found it interesting, and hand back over to Graham.
Keith, thanks very much for that really fascinating summary and insight into the work that's going on within Meggitt. I'd like to follow on from some of the themes that Keith's introduced to look at IBM's perspective on the scope of what cognitive manufacturing covers, where it can deliver business benefits, and perhaps how to simplify and demystify the implementation. So there are a few steps that come to mind when considering moving into cognitive manufacturing. And fundamentally, we start with the data, whether that comes from new sensors that are instrumented in your factories, or whether it comes from existing data that's in your manufacturing ecosystem, such as the typical systems that we find in manufacturing execution systems, enterprise resource planning systems such as SAP, and also enterprise asset management systems such as IBM's own Maximo. However, a lot of this data doesn't currently talk to each other. They're used for their own specific purposes and they remain in their own silos. So the concept of moving towards a cognitive manufacturing environment is to break down those barriers between data. So now your MES information can talk to your ERP system, which can talk to your enterprise asset management system, and this gives a much better understanding of your entire manufacturing system. So the first level, typically, of cognitive manufacturing is to make the data you've gathered transparent. That is to say, the use of various visualization tools to see how the data comes together and how they interact with each other. And that allows you to start to distinguish some patterns that you see in the data. But we believe that's not enough. Ultimately, what you want to get to is taking your data into action. And in order to get to that action, you have to do something with the data, whether that means analysing it, processing it, or using the data to monitor the state of your manufacturing operations. And then to be able to be smarter with the data by making predictions or by responding to how your data and its insights are driving you to insight and guiding your actions. All of this drives us to address some of the fundamental use cases for cognitive manufacturing. IBM's interviewed many executives for its Institute of Business Value, or IBV, studies, And we asked them what do they believe will deliver the biggest value that's important to them in terms of applying Internet of Things and cognitive technologies to a manufacturing organisation. And the answers are shown at the bottom of this chart. It's about smarter equipment maintenance, or improving quality, improving employee safety, or reducing costs through smarter energy management. And furthermore, the business benefits that will be driven by these capabilities typically appear in availability, or minimisation of downtime, in performance to optimise throughput and profit, and in quality in terms of yield and process quality. Now, these metrics are very familiar to anyone working in manufacturing and are often combined into the overall KPI of overall equipment effectiveness, or OEE. Moving on to this next slide, we take the information from those IBV studies, as well as conversations we've had with our clients, with industry experts and with analysts, and we've identified three major pillars of manufacturing value. And it's these pillars that have underpinned the industry solutions that IBM's developed. So here we're looking at use cases that are purpose-driven and specific to a business need. And we can use the Watson IoT for manufacturing solutions to drive those manufacturing operation improvements. These use cases categorise themselves quite neatly into three pillars. The first being intelligent assets and equipment. The second is cognitive processes and operations. And the third is smarter resource and optimisation. Or to put it more succinctly, it's about things, about processes and about resources. In the first pillar, we're looking to ensure that manufacturing assets are up, they're available and producing at the right levels of performance. And we can expand on the use of enterprise asset management systems, such as Maximo, to build predictive analytic models to really drill down into the key aspects of machine reliability and to reduce the downtime. Now, IBM's approach in this pillar is to deliver pre-built predictive and prescriptive industry models. This is an evolution of the approach from a few years ago, when big data and analytics projects were driven by a custom or bespoke approach. But what we see more and more with our clients is they don't want to start from zero. They prefer to build upon use cases and models that have been successfully applied before in their industry. So IBM is building more and more industry models that are tailored to those specific industry sectors, such as automotive or electronics or aerospace, and are based on a better understanding of the assets and equipment. The second pillar focuses on manufacturing performance and quality. This expands across not only the manufacturing process itself, but can also go back into the design and verification and through the manufacturing process itself, and then into the aftermarket and service phase of the product lifecycle. And in the quality process, it's often the case that inspection techniques will involve unstructured data sources such as images or recordings. Now, IBM's continuing to build our cognitive capabilities into this domain. For example, we've recently announced the Cognitive Visual Inspection solution, which uses an ultra-high definition camera and cognitive capabilities from IBM Watson to capture images of products as they move through the production and assembly process. This acts as a cognitive assistant to human inspectors. It's never going to be a replacement for that, but it can help to detect defects in products, including scratches and pinhole-sized punctures. This solution's also got a continuous learning capability, again based on a human assessment of the defect classifications in the images. In the third pillar, we're working with clients on aspects such as worker safety and health and safety legislation compliance, as well as cost reduction through more energy optimization, more efficient energy optimization. And another way in which we can apply cognitive capabilities to increase worker productivity and expertise is to use Watson to collate and share engineering experience across the organisation. The line that was used by one of our clients is, "We teach Watson to think like an engineer, and Watson teaches us to think like 1,000 engineers from 1,000 different sources." And this type of cognitive capability can be applied to reduce onboarding time for new recruits into the business and training time for new engineers, and also for faster resolution of problems as they crop up. So looking at these pillars, it's a business improvement and use case driven approach, rather than considering the plethora of technologies that might be categorised under 4IR or Industry 4. And we find this to be a useful and constructive way to have a conversation with our clients in order to prioritise where they believe their most urgent issues are and which are the most likely areas of improvement and business benefit. So in the next slide, we're looking at the straightforward approach that IBM's developed for embracing cognitive manufacturing, and it relies on taking what we call logical steps to value. Starting on the left, the first principle is gathering of existing data, with data which can come from systems, ERP, MES as I mentioned, but can also come directly from machines and equipment, from robots and from sensors. And IBM's Watson IoT platform can be applied into this process of gathering and collating the manufacturing data. The next step is to visualise the patterns that exist within and across the data sets, and this can be done through dashboards using graphical representations to see the patterns. Bluemix is IBM's open cloud platform that facilitates the easy visualisation of such data and reports. And in some customer cases, we've worked with them to use the Watson Analytics tool to deliver a cloud-based operations dashboard. And this visualises and shares manufacturing reports across the organisation. Those reports have often been created within the business previously, but they may have been locked away in departmental systems or on paper-based reports that aren't necessarily distributed very well. That visualisation, however, can only take you so far. So step 3 shows the implementation of analytics to gain better insight. We can deliver both predictive capabilities to anticipate problems before they occur, and also prescriptive models which offer context-driven recommendations on how to react to various scenarios and of what might happen in the future. This is based on learning best practice from your own organisation. In the manufacturing arena, we can apply these prescriptive models into applications such as inventory optimisation, into production planning and maintenance scheduling. And the fourth step we're looking at here is the adoption of cognitive capabilities. That is to say, new ways to process the structured and unstructured data, such as image, video and acoustics information, and potentially interacting based on a natural language interface. One example of this is the visual inspection solution I just mentioned, or another example would be building cognitive technical manuals which will increase the first-time fix rate in resolving production problems on plant and equipment. So in conclusion, we've looked at the various business applications of technology in the Industry 4 domain, and we've reviewed some of the use cases and solutions that IBM offers in the manufacturing sector. And we've considered a stepped approach to adoption of those capabilities. With that, I'd like to thank everyone for joining, and we'd open up the call for question and answers.
Graham, thanks very much. That's terrific. Bless your heart for that. We've got some questions. I want to start with one, Graham. It's inevitable, obviously. When people talk about connected anything these days, they worry about security. We've just had that recent WannaCry ransomware attack. Obviously, people are going to be saying, yes, we want to get connected, but what about security? What considerations do you recommend when implementing cognitive manufacturing? What approach should manufacturers take under these circumstances?
It certainly is a risk that everybody going down this path needs to be aware of. I'd say the approach we've developed and would recommend to people is a sort of 4-step approach. You may well need to bring in external security consultants who have experience with security on SCADA and PCS systems, but you may have those people within your own organisation. But the first step would really be around an audit and assessment of knowing what you need to protect and how you're going to do it. Then secondly, to look at developing secure business solutions. The implementation of the Internet of Things into the industrial domain, it could open up new vulnerabilities or ingress points that hostile agents, as Keith mentioned, could try and exploit to get access to your core systems, to your IP. But there are many tools on the market. IBM has its own security portfolio, but you need to have clear and up-to-date security solutions into that domain. Thirdly, you need a plan for mitigation of any security event once it's identified, and mitigation of any future impact. And finally, using the latest security intelligence and patches and so on, so everything is maintained up to date. So, at a very broad brush level, again, 4 steps really as to how to consider to address that threat.
Graham, thanks. Right, let's move on to a more specific thing about investment. A lot of the people who are listening to this, Graham and Keith, are thinking to themselves, well, yeah, this looks revolutionary, but does it have to be adopted in a big bang fashion? Or are there incremental ways in which companies can invest and plan for investment over a longer period in order to introduce these capabilities over a stepped period? Keith, why don't you join in on that one?
Yeah, I think it's a very good question. It's one that we've had to think about. And if you think about it practically, a big bang solution probably just isn't going to happen. I can't imagine there's many companies that will be prepared to take a number of their factories and completely move them over on a digital revolution to be completely differently organized under an I4 regime. I think you do have to find that the incremental changes, but the problem, and apply those and gain confidence. The problem you'll get with that is if you take a piecemeal solution, you may not get all of the advantages that you want out of the individual piecemeal steps. So I think it's very important that, again, you understand where you're going, and you build a bit of a roadmap around things. So if you're doing some incremental implementations of your I4 technologies, that you think of the step, but also how that mixes with other technologies and what the follow-on steps were. So from our point of view, we talked about the Claw workstation, where we apply that for the manual assembly of a lot of our products, but we've also understood how we're going to take some of those technologies and roll them out elsewhere, and the sort of data we get from that and the sort of data we're going to get from elsewhere in our business, and how that's going to be conjoined. So I think the point is, it's very unlikely that anyone will do a big bang around this. It will have to be incremental, but you need to do that with quite a clear roadmap, which again, from our point of view, few generic solutions around that. You have to understand your business and your needs.
Graham, what about your thoughts on that? Go ahead, please.
I'd echo what Keith just said entirely, Nick. I think for a lot of organisations, that's the way it's best to move forward. Identify the capability, the technology that's going to deliver some rapid benefit into the organisation. Use techniques, like agile development. IBM has a process of what we call design thinking to aid that process to move things forward to a viable product, a viable solution very quickly, and then use the benefits that are yielded from it to fund the next step in a sort of sequential approach to moving on to the next step, rather than trying to take a massive strategic overview from the beginning. You can take viable steps one at a time.
Okay, a question for both of you, and perhaps Keith, you can pick up first. We hear a lot about large companies, as yourself, of course, and even bigger ones like Rolls-Royce and JLR, and it's obvious that they are going to get heavily involved up front with these technologies. But what about SMEs? What about companies, 2 to 30 person companies? They make up much, indeed most, of the UK manufacturing economy. Isn't there a risk that they're going to get left behind on this?
Yeah, I think it's a very real concern. And actually, when we look at countries like Germany, who are perhaps leaders in this Industry 4.0, they have the same concern about how they're going to bring along the SMEs. I know there are some activities going on in the UK and in Germany to try and build demonstrators and do some brokering to bring the technology suppliers like IBM and then the technology users and the smaller technology companies together, so they can see what's required. I think one of the things that we've tried doing, but I'm not sure if it's going to be universally rolled out, is to have the concept of some sort of portals into our system. And these portals will allow certain suppliers to tap into some of our industry for intelligence. So, for instance, if they want or need to change the delivery or the scheduling of the parts that's coming into us, sometimes we might be able to accommodate that with very little pain, and we can give them a bit of relief on that. Other times, if they're a couple of hours late, that might cause a huge amount of pain on us, and to give them that sort of instantaneous connectivity about the consequences of certain decisions can help them. So we're looking at how they can achieve that through portals to come into some of our bigger systems. But that's just technique. So I'm getting echo now.
From my side, Nick, again, completely agree. With what both you and Keith were saying there. I think there is obviously for organisations of that sort of size and scale, there's a great deal of scrutiny will have to be applied to any investments into this type of capability versus the benefit that's going to be delivered to them. I'm sure everyone's aware. The UK government's putting quite a lot of focus into this through the Catapult Centres for Advanced Manufacturing. We're doing quite a bit of work with the Advanced Manufacturing Research Centre associated to the University of Sheffield, and I think for a lot of organisations of that sort of size, I'd recommend getting involved in those sorts of initiatives to get deeper understanding and maybe work out what the best first step is.
And of course, we are going to be waiting for the results of the Industrial Digitalization Review, which is being conducted by Jürgen Meyer from Siemens and a load of industry experts and peers. A quick question from the audience. For you, I suspect, Graham, but Keith will have his views. What are the key challenges when testing these solutions? I mean, is all data being captured? Are the analytic solutions presenting the data correctly? And if we're going to make confident, accurate decisions, then the solutions need to be accurate as well. How do you test for that, Graham?
The only way to test is to do it for real in some sort of proof of technology. We've been engaged in a number of these things with organisations of various sizes. I take the point Keith made during his presentation about the quality of the data being important. But I would say, in the exercises we've been involved with, the data doesn't have to be perfect to yield, real insight and good results. We've taken some data from some of our clients and trying to build predictive analytic models based on them. The client's gone into the exercise quite skeptical that we will find anything because they felt the quality of the data was questionable, incomplete, possibly corrupted. But even with that sort of quality of data, we've been able to prove back, on sort of retrospective tests against what was actually experienced in real life, that the data and the analytic models can be built and can deliver some really useful insight.
We've got one more question. We'll make it the last because time is running away with us. This is also from the audience. A question for both speakers. Given that 4IR is a coming together of the world of engineering and IT, how important are frameworks such as those provided by the Industrial Internet Consortium to speed adoption and reduce risk? Keith, that one for you?
Yeah, it's actually an interesting one because I think frameworks and standards are very important. But one of the things that I do wonder about this when we bring the IT industry together and the manufacturing industry, as we talked right at the start, there's different sort of paces and responses that both those industries are used to, and certainly quite a lot in the IT industry. The standards evolve out of what has happened, and so they tend to be a bit more of a retrospective documentation of what has happened, and that's actually been quite good for the industry. Whereas we tend to be a bit more upfront, formal in the manufacturing side of the business. So I'm not quite sure how that will play out, but I do think trying to get standards and get as much concrete as possible as soon as possible is a very valuable thing that we should be doing across the industries.
And Graham, your thoughts on that?
Similarly, I applaud and support initiatives towards standardization in this area, but equally I wouldn't advise anybody to wait for those standards to become really mature and universally deployed. I think it's going to take a while for that to happen. And the time is ripe now to really move forward and take advantage of these capabilities.
Well, I suppose really to both of you, just as a final point, we've heard some fascinating discussion of application of these technologies, but anybody listening to this, what is the correct next step for them to take? Graham, do you want to conclude on that?
For anybody who wants to follow up this conversation with myself, my contact details will be made available. Very happy to speak to anybody in follow-up and planning the next step.
And Keith, what about yourself as a manufacturer? You're obviously sympathetic to people saying, well, we want to catch this train, but we just want to make certain that we get on board in the right way. What's the best first step that you would recommend?
Yeah, I think it might be very tempting to say it's too big and too complicated, so just wait for another train and to continue that metaphor. And I think that would probably not be a wise move. I think there's a lot of people out there. The catapult sensors were mentioned, like the MTC, the AMRC, and various other things from the UK government. I would take a bit of time to engage and understand and reflect back to what we said, said right at the beginning. Understand what you need for your business and talk to some of the people who are experts in the field and see how it can apply to you. Maybe waiting is right, but you might be missing an opportunity. So I wouldn't go nuts, but I would say get the awareness and investigations going.
Well, thank you very much indeed, Keith and Graham. Everyone, I'm afraid that's all we've got time for today. If you've got any more questions, please do not hesitate to get in touch with either Keith or Graham, or indeed ourselves if it's aimed at the manufacturer. Our contact details will be on the final slide. We will be sending a copy of the entire video presentation, webinar presentation, to all registrants. If there's anybody you think would benefit from joining in, having a look at it afterwards, do please pass that link across. So I wrap up by saying a very big thank you to our friends at IBM for sponsoring today's event, to Graham Cox from IBM and to Professor Keith Jackson from Meggitt. I hope you really enjoyed the presentation. I thought it was absolutely brilliant. That's all from us, from Graham, Keith and myself. Thank you for joining us and goodbye. And on behalf of the manufacturer, I'm Nick Peters. Goodbye for now.